Go get them. Right. Yeah, I'll borrow this. Have you got one? Right, so you can share. So I'll do this V3 one here, okay? Can you see that? Not quite. Not quite. This one. Near the front. Near the front. No, near the front. Wait a minute. Wow, look who decided to show up. Thinking it's the last class, whatever. Let's see if I got enough battery power. I'll have to plug it in a moment. Okay. Do you all have this open now? Yeah. So I'll put this up on Moodle as well, but I'll just call it like final lesson or revision lesson. I'll put it at the end of the list of lessons or something before the revision book, something like that. Okay, so here. What type of function, I should really say what type of mapping, is this? So is it one, many, one, many, or many, many?
Many.
And the answer is?
Many.
Correct. It is many to many. And the reason is, if you remember, one quick way to check. Yeah. Here it cuts twice. And then vertically as well it can cut twice. So this makes it the many to many. It's only one mark, so that should be it. On a separate one, sketch the following. So again, it's another sketch one. So here's part 2. I'll just draw mine on the same diagram, okay? So here's the original. That's A, minus A, minus A. So the first one is y equals 2fx. So what happens here? No. Yeah, so in fact it will turn into this shape. Yes. Y equals fx minus a. So what happens for this one? Right, yeah. A units. So this one now will go here. The center will go here, and this one will go here. So, and this point is 2a. You just move it to the right. Yeah. Okay. B. Is that it for A? So bad. Not so bad. Right, so B part. You have gx equals x squared minus 9. X is from minus 2 to 3. Hx equals 2x minus 3. X is from 0 to infinity. Yeah. What is the range of G? So I think it's...
minus 3 to infinity.
No. We'll draw it. We'll just draw it. It'll be the easiest thing. So here's G. So when I put in minus 2, I get, what do I get? Minus 2 is minus 5. So it's here. When I put in 0, I get minus 9. Minus 9. And then when I put in 3, what do I get? 0. So it's up here. So the graph looks like this. So the range, well, I don't even know that minus 9 is the lowest point. It will be, but I don't know that just yet. It will be, but I don't know that just yet. Yeah, it will be minus 9 to infinity. No, not to infinity. To 0, because it stops here. It's just this is the range. Because of this, yes. So the range is from minus 9 to 0. Now I know the minimum is actually minus 9 because when I look at this, if x is any number, it will make the answer bigger, because if it's positive or negative and you square it, what will it be? Be positive. So the smallest I can make this is when x is 0, which means minus 9 is the minimum. It's like complete the square. It's in this form. You know, you can think of it as x plus 0 squared minus 9. You can see that the minimum's at minus 9, and this happens when x is 0, from semester 1. So anyway, that's the range, minus 9 to infinity. The next part is, what is the inverse of h? Oh, so easy. You want to try and guess it from looking at it? So if you look at hx, what does hx do? It takes x and first... Yeah, well, yes, we'll just go through the process. So what's the first thing h does? It takes x and... No. If I look at what h does, what does it do to x? First it multiplies it by 2 and then minus 3. So first it adds 2 and then it's minus 3. Yeah, so if we go backwards, what's the opposite of minus 3? Plus 3, and then multiply 2, divide 2. So the inverse should be x plus 3 divided by 2. And you can check this by using the other method I showed you. If you rearrange this, you get the same answer. But because it's linear, you can almost do it in your head, which we did. And lastly, actually this is a really good question. Solve gh of x equal to minus 8. So that's g of 2x minus 3 equal to 8. That is 2x minus 3 squared minus 9 equal to 8. 4x squared minus 12x plus 9 minus 9 equals 8. 4x squared minus 12x minus 8 equals 0. X squared minus 3x minus 2 equals 0. X minus 2x minus... Oh. Maybe it has ugly roots. No, sorry, my mistake. I lost my minus here, look. Minus, 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 plus 2. Now it's better. X minus 2, x minus 1. So, x equals 1 or 2. Yeah. That's it. Same paper? No, A6. You said A6, didn't you? Yeah. It looks okay. A6. dy dx equals 1 minus 1 over x minus 1 over x squared. Find the equation of the line. In fact, this is an ODE. We have to work out the y. So, we get dy equals 1 minus 1 over x minus 2 dx. Integrate.
Y equals
Go on.
minus two plus 2x minus 1.
Should be like this. Well, sorry, that's a minus there. You add 1 to the power, which makes it minus 1. Yeah. So you get y equals x minus log x plus 1 over x plus c. You can find the c because they give you a point. The point is 1, 0. So 0 equals 1 minus log 1 plus 1 plus c. So c is minus 2. So the answer is y equals x minus log x plus 1 over x minus 2. By part? By part. We shall do A9 next. Huh? I would be impressed if you got the right answer. What? Hold on, I can only do one at a time. So I'm going to do A9 now. Yes. Okay, A9. Integration by parts. Integrate 0, 1. I'll take the 5 out. No, I'll leave the 5 inside. 5x e 5x dx. Hold on. F derivative, g derivative, that's e 5x, that's 1/5 e 5x, 5x, 5. It's boring, that's what it is. F g
minus 5 e 1 over 5 e 5.
Boring and boring. So, and then integrate e 5x dx. Yes. Why did you ask me for this one? Well, it's not. E 5x over 5, and then we put in our limits of 0 and 1. So if I put 1 in first, I'll get E5 minus 1/5 E5. And then if I put in 0, I'll get 0 minus 1 over 5. So the exact answer would be 4/5 E power 5 plus 1/5. But they actually don't even say the exact answer. If you like. What? Which one? Okay, I believe you. Let's look at A4 then. Can I go to A4? Alright, if u equals 1 plus x, what's du dx? 1. So what's du? Yes. And by the way, what's x equal to?
U minus 1.
Alright, so here, this x on the top is u minus 1, and this 1 plus x on the bottom is u, and the dx? Du. If I divide, u over u is 1, and 1 over u is 1 over u. And if I integrate, I get u minus log u, which is actually 1 plus x minus log 1 plus x. But we have to put in limits, 0 and 1. So if I put the 1 in first, I'll get 2 minus log 2, and if I put the 0 in next, I'll get 1 minus log 1, which is 0. So this will be 1 minus log 2.
0.346.
And don't forget your calculator can check the answer because you have an integrate button on it. Yeah? Not so bad. On the next paper. No. It's too similar to what I did in class. I want something different. Which one? Which first paper? Yeah, which one? On the second paper. I will do A3 and B5 on the second paper. Now, if you remember when we did this in class, I told you you need to remember these special values. It's quite generous that they gave you the values in the question. Remember I drew the two triangles? The triangle with the 1, 1, root 2, and then the other triangle was 1, 1, root 2. Do you remember in semester 1 I said these triangles you should have memorized? It's 1, 1 and root 2, and this is, you remember, 45, and this one? 45. And the other triangle you need to remember is this one, which is 1, 2 and root 3. And this angle here, 60, good, and this one, 30. So you can use these triangles to remember what sine 30 is. What's sine 30 here? Aha! Which is what they say here. And what's cos 30? Which they also say. So it's quite generous that they gave you this information because you should be remembering this. You should remember it. Anyway, back to the question. They tell you sine 30 is a half because they feel sorry for you. And they tell you cos 30 is root 3 over 2. And they tell you that sine 45 equals 1 over root 2. And cos 45 also equals 1 over root 2. Sine 75, what is it? Well, that is sine 45 plus 30. Remember doing this?
Yes.
So this is sine A cos B plus sine B and then cos A. So that is 1 over root 2, root 3 over 2, plus 1 over 2, 1 over root 2, which equals root 3 plus 1 over 2 root 2. And we're finished. Easy peasy, lemon squeezy. B... What one did you say, who? B5. Yeah. I'm going to bypass one. Can I go down? Yep. B5, A1. It's very similar. Listen, don't forget for this one, don't forget it needs to be written like this, log x times 2x. So remember this. Yes, f derivative, g derivative, log x, 1 over x, 2x, x squared, the 2's cancel. Yep. And that's 2x. Okay, so the rule is this is equal to f g minus f derivative g, which is equal to x squared log x minus integrate x, which is what? It's x squared over 2 plus c. If you like, x squared log x minus a half plus c. Right, that's the first part, part 1. Part 2, you have to use your answer. They say dy dx equals 2x log x. So what you do, and they give us a point. So you bring the dx up. Have you seen this problem before?
Just a second.
Yes. Quite recently we've seen it. So this will be y equals x squared log x minus x squared over 2 plus c. To find the c, use a point, and the point they give us is 2e squared equals e squared log e minus e squared over 2 plus c. What's this? This is 1. And this is 2e squared equals a half e squared plus c. So therefore c equals 1.5 e squared. So our answer is y equals x squared log x minus a half x squared plus 3 over 2e squared. Like what? Yeah, well I just felt like it. Why not? Okay, the next one is a partial fraction one. It looks pretty normal to me. We multiply everything by the denominator, so we end up with 9 equal to a x minus 1 squared plus b x plus 2 x minus 1 plus c x plus 2. Alright, so what are we, this is minus 1 in the middle. So let's say firstly we make x equal 1. So then I get 9 equal to 3c, so c equals 3. Next, x equals minus 2. So then I get 9 equals 9a, gone and gone. So then a equals 1. And lastly, I can just make x equal to 0. So I get 9 equals a plus b times 2 plus 6, 7, 8, 9, b equals 1.
Now, why did it multiply x minus 1 squared not 2?
What you talking about? What's your question? Sorry? Are you sure?
Yeah, why did you do x minus 1 2?
It's x minus 1 squared here. So why do we need the cubed?
Because when it is a big square, we have to do.
Oh, they did. You see, there's x minus 1 and there's x minus 1 squared. So it's twice. Yeah. And if you remember, sometimes with these, instead of having a C, what else could you have to have? CX, yeah. Or, yeah. But we don't have to worry about that here because they give you the form. Please concentrate like it was serious. Okay, so the last part is the integration from 2 to 3, A plus B plus C. And I'm going to change C into a power like this. Or you don't have to. You can leave it. You can leave it as a fraction if you want. Okay, how do we integrate the first one? Well, that's easy. What is it? Yeah. The second one? Yeah. Now this last one, what do we need to do for it? What is it? Hang on. Substitute what? Is what? U. So you make a substitution here for the last one. Okay? And when you do a substitution, increase the power by 1, the backward power. You'll get this as the answer when you do it. Okay? It's actually an easy one because if u equals x plus 1, what does du dx equal? 1. Yeah, so what does du equal? Dx. So you really just have here 3 over u squared du. So this is u power minus 2. What do we do to the power to integrate? Plus 1. So it's u power minus 1 over minus 1. So I'm sorry, in fact, I should have a minus here. That is straightforward. I'm not going through the details of that. We put in our limits, 2 and 3. So if I put in the 3 first, this will be log 5 plus log 2 minus 3 over 2. And if I put the 2 in, it's log 4 plus log 1, 3. Yeah. So log 1 is 0. This will be log 10. Log 10 over 4, which is log 5 over 2. Minus 3 over 2, minus 9 over 2. No, that's plus. So plus. So 3 minus 3 over 2 is 3 over 2. So this would be the answer here. Or, if you want, 3 over 2 plus log 5 over 2. Because they tell you in the question to write the answer like this. Yeah, it looks like that, but in fact what really happened was log 5 plus log 2 is log 10. And then here is minus log 4, which is log 10 over 4, which is actually log 5 over 2. So there's actually a couple of steps that went into making this.
But you didn't have to show them anything.
No, this is fine. I just make it look easy. No, I just make it look easy.
Okay.
Yep.
So we just go over the circle with the offshoots and acute angles for the line.
Yeah, but I need it.
Question
Yeah.
is the paper A3.
Which one?
A3 and
A3 on the first paper. Yeah. A3 on the first paper. So what we do first, hey, come on. Sine A equals 24 over 25.
You draw the time.
Yes. Now, this will be 24. This will be 25. What is it? 7, yeah? For sure?
Yeah.
Yep, okay. Now, you have now cos A equals 7 over 25, and tan A equals
24 over 7.
24 over 7. However, what you don't know is if it's a plus or minus, or if it's a plus or minus. You're not sure of the sign here. Yes? Oh, I know. Yeah. So it's obtuse. So what we do is we draw our circle. Everything is positive here. Only sine, only tan, and only cos.
Or minus.
Shh, please. I'm trying to concentrate. Lena is very confusing to me with her difficult questions. So, we know that A is obtuse. So that means we know that it could be here. Well, I suppose it could be here as well, because obtuse usually means more than 90, but we usually call these two, what? Reflex. Anyways, it's there. Now, we know that sine is positive, because this is given to us. Right? This is given. So we know sine is positive. So that means sine can only be here or here. These are the only places sine is positive. Everything's positive here, only sine is positive here. Now, we also know because it's obtuse, it could be in one of these. But these ones are no good, because sine will be negative here. So it must be, we must be here in the second quadrant. What does that make cos then? Negative. Now don't forget tan is also sine over cos. If sine is positive and if cos is negative, therefore it's negative.
And then reflect all of them.
No. No. Oh yes. In the here sine and cos are negative, but tan is positive. Yeah. Right, so now we can answer the question, what is the square root of 1 minus cos A? That is the square root of 1, yeah, because it's minus minus. So this would be 6 over 5? Is that right?
The answer will be 4, square root 2 over 5.
Oh, it's not a nice number. It'll be, what is it?
32 over 25.
With a square root?
No, 4 square root 2 over 25.
Hold on. What is it, Yusuf?
4 square root 2 over 5.
Like this.
Yeah.
And it's going to be negative.
No. This is where there's a mistake in the marking scheme. The marking scheme reports that both answers should be taken here, which is completely wrong, because if I asked you for the square root of 9, you should only tell me 3. If I said what's the square root of 9, you say 3. So if I said what's the square root of blah, you just need to give me a positive answer. The marking scheme gives both positive and negative, which is incorrect. We should. I don't bother to say anything because. Yeah. Well, I don't bother to say anything because I will only point out a mistake if it affects anybody's grade. So if somebody was 1 mark away from a higher grade and there was a mistake in the question, then I'll say something. But otherwise I'll just be quiet. Huh? What? Yeah, but all that matters is your grade. So if one person in this room was 1 mark away from the next grade and they were 1 mark away because of a mistake, then I'll say something. Otherwise I'll say nothing.
Yeah. If I get the same question, that's the root, then I'll say it. Right? If I got 1 minus...
Yeah, so just to be clear, this technically is the correct answer. However, the marking scheme says this is the correct answer. Therefore, if students wrote this, which is correct, I can't give them full marks because the marking scheme says this is the right answer. So you'll get something like 2 out of 3, even though you're getting the right answer. Now you might say that's not fair, and you're right, it's not. And in my experience, I'd say about 50% of the exams would have one mistake in it, which would cost you 1 mark, or 1%, but only half the time. And besides, if anybody's grade was affected by this, I would say something and make sure they get full marks. Otherwise, there's no point in saying anything, because it's not like your grade changes, and all that matters is what grade you get. So, you know, when you want to go on to do medicine or whatever, you need an A. So if you get 69, then I'll say something. But if you got 72, then who cares? I sure don't. Yeah. Okay, anything else from this? We've got a couple.
If we have this type of question, do we still put the second line?
No, go with what's right, not what you think the examiner may think is right, okay? So go with what you think is right. Because after all, maybe somebody mentioned this mistake to the person and the next exam would not have it. So I'm just saying this is why I don't always think giving people a marking scheme is a great idea, because as the physics students saw earlier, I gave them the marking scheme to one of the questions in section B. And I don't know if you found that helpful, but it doesn't have all the steps in it. It doesn't have all the processes in it. So it's only really useful to see if you got the final answer correct, really. I don't know how this compares for chemistry or biology. I know Colin says for biology he doesn't think the marking scheme is any good, and he has his own notes.
It doesn't help because in biology it only gives you keywords.
Exactly, anyway. Yeah, so it's no good. What about chemistry then? It does have some steps. Yeah. But for the maths you have the videos.
They want them to show hours.
Huh?
Yeah.
What?
They take marks from the hours. You put the hours, you take marks. You don't see them.
You mean there's a vector question in chemistry?
Oh yes, the vector question.
There is another
For chemistry.
And polymerization of if in the hours you have to show them.
You get marks for the arrows?
Yeah.
In what? Chemistry?
Yeah.
Is this your, like, you mean like H2 plus O arrow?
No.
Oh, which way the electrons move?
Yeah. So which atom or
Oh, like all this kind of...
yeah. And the hawk and
What? And then you have like this here, something, and then something here, and it goes over here, and then this one jumps over here, and then this one here, over to here, yeah, and then into a car and accelerates this way. Something like this? Yeah, okay, yeah. Right, anything else you need to see in this? So when is the exam next week? Oh dear. When is your exam next week? Wednesday. What time? 9:30, I believe, yes. Please don't forget to look at Moodle and practice some of these. Has anybody done all of the exams on Moodle? No. So nobody needs more. You have enough, yes? So what did I say we have in total? 7 in the revision book. But if you look at the revision book now, I included the practice exam I gave you. So there's 8 in the revision book. And also you have these 2 exams here. So you have 10 in total. I would strongly recommend that these 2 you try over the weekend, and then also review the practice one I gave you, and then whatever extra time you have you can do more exams, but as a minimum for the exam on Wednesday you should have these 2 done at home fully, all of them, including the questions you won't do, because maybe something that will move from section B into section A, okay? And review the 2015 exam. So make sure you're happy with those 3 exams, and then do extra ones, if you can. but I know your first exam is chemistry, so I'm sure you'll probably have...
No, our second exam is
Well, I'm not counting EAP.
yeah.
So are people going to spend their weekend studying chemistry and bio and forget about maths, or
No.
why not?
It's going to be a try after.
Yes. So how long does it take to do a maths exam?
2 hours.
2 hours. So give yourself, 3 hours on Saturday, 3 hours on Sunday, and then later in the week. When's your chemistry exam? Tuesday? What time? So then in the afternoon on Tuesday, after the exam, you can do another maths paper. Yeah, well, I know you have to give time to chemistry as well, and biology. So I'm just saying, as a minimum, do 2 maths papers, one on Saturday, one on Sunday, and then review the 2015 paper I gave you, maybe try some questions in that again on Tuesday evening. Yeah? I can't say any more, I can't give you any more advice. Yeah? Have a good breakfast and a good night's sleep as well. Yeah? Don't think you can do a long study night the night before the exam and this will work. Because I have seen students fall asleep in the maths exam for about 30 minutes because they stayed up late cramming. Not joking. You sit doing the exam and then... what do you think?
No. Since he knows.
What do you think? Yes or no? Did I wake him up? What do you think?
Yeah.
I did not. So just remember that. Okay? Yes, I respect his privacy. If he wants to sleep, he can.